Hello students, in the previous class we have started applications of derivatives and we have seen what is the rate of change as well as monotonicity, and we are discussing what is maxima and minima. We have seen the definition of maxima and minima and then solved a few problems. Now we will continue with this topic. Yes, we have completed this. Yes. Now we have to start from this slide. Okay. First derivative test. Method of finding extrema of first continuous functions. This is applicable for continuous function. All continuous functions may or may not be differentiable, but if a function is continuous as well as it is differentiable, then we can use this method to find maxima or minima. Method of finding extrema of continuous functions. It is not only continuous, the function should be differentiable as well. Then we can use this method to find maxima or minima. Now what is this first derivative test? I will explain this in short what it is. First derivative test is nothing but first we have to find the derivative and using that find at which point the value becomes maxima or minimum. We will consider one curve. For example, take any random curve. Now which is maxima or which is minima point of this curve? Obviously in the neighborhood, in the interval that is defined for this curve, whichever value that is having maximum point, that will be local maxima. So this is a local maxima in its neighborhood. So in the neighborhood of this point, this value is maximum. That is the definition of maxima or minima. Similarly, this point will be minimum. Why is that? Because in the neighborhood of this point, this value f of b, say this is f of a f of a, b, f of b. This b point attains minimum value. F of b is the minimum value of this curve. Similarly, this point will be maximum point because in the neighborhood of this point c, this value attains maximum. Similarly, this point will be minimum point d. So what is the understanding from this? In the neighborhood of the point, the value should be either maximum or minimum point. Then we can say it is maxima or minima. Now how to identify if a function has maximum or minimum value by using first derivative test? It is very simple. What is the observation when we see this curve? Is it is a continuous function? Yes. And it should be differentiable also. Then we can use this method. And what is the condition? Here at this, in the left side of this point, this value tangent to the curve has a positive slope. Yes or no? Tangent has a positive slope because it makes an acute angle with x-axis. So this is a positive slope. And what about this curve? This side of point A, tangent has a negative slope. So here actually tangent changes its sign from positive to negative, then the point will be maximum. What is the tangent at this point? Slope of tangent at this point? It will be 0. So that means tangent actually changes its slope from positive to negative through 0. So at the f dash of this point, value will become 0 and it changes its sign. First derivative of this function f of x changes its sign from positive to negative, then that point will be maximum. Similarly, what is the minimum point? Again, the slope of this tangent is negative here in the left neighborhood of point B and it becomes positive in the right neighborhood of B. So what is the understanding? Slope, actually tangent changes its slope from negative to positive. Then we can say it is point of minimum. So what is the understanding? When a function increases and then decrease, then that point will be maximum. That means tangent will be positive and then get negative through 0. That will be maximum point. Similarly, for minimum point, tangent will decrease, slope of tangent will be negative, and then it will change to positive through 0. That is the understanding. So what is first derivative test, students? Again, this is the same for these 2 points. Here also tangent changes its slope from positive to negative. For this case, negative to positive. So when a tangent changes its slope from positive to negative, it is a point of maximum, and when it changes its slope from negative to positive, then it is a point of minimum. So that is the first derivative test. Now we will delete this and see what is given here. Okay, first derivative test is, let f be a differentiable function, not only continuous, the function has to be differentiable also, defined on the neighborhood of point A. Then A is a stationary point of f such that in the interval, in the neighborhood of A, that is A minus delta to A plus delta, does not contain any other point for which alpha is a point of local maximum if f dash changes its sign from, when it will be maximum, students, it will change sign from positive to negative. F dash changes its sign from positive to negative. And what about minimum point? It will change from negative to positive. So this is the first condition for maximum. And for minimum, f dash changes its sign from negative to positive at this point. So that is the maximum or minimum definition identification through first derivative test. And this is very important. Here, point of maximum or minimum is not possible when f dash does not change its sign at this point. Sometimes what will happen is, the value gets increasing, slope gets increasing, that means f dash will be positive, and at a point it will become 0, and then it will again start to increase, or it will decrease, become 0, and again start to decrease. That means at those points, even though f dash becomes 0, it is not a point of maximum or minimum. For example, find the extreme value of f of x equal to x square minus 6x plus 8 on all real numbers by using the first derivative test. Okay, easy question. What is the first step, students? For finding if a point of maximum or minimum, local extreme means maximum as well as minimum value. What we need to do? First find f dash of x. What is f dash of x? 2x minus 6. 2x minus 6. What is the next step? Equate f dash of x equal to 0. Which means 2x minus 6 equal to 0, or x is equal to 3. Next, what we need to do? Mark this point on the number line 3, and this function is defined on all real numbers. So between minus infinity to infinity, this is a sine of f dash of x curve. Sine of f dash of x. Substitute some value that is more than 3 in this point for f dash of x. Then what will you get? If the value of f dash of x, it is more than 3, x is more than 3, then f dash of x will always be positive. So this is positive. When this value is less than 3, for example 0, then this is a negative number. So in this interval, minus infinity to 3, f dash is negative. And there is no other term for which f dash changes from positive to negative. Here f dash changes the sign from negative to positive. So by drawing a rough graph, in this interval the function is decreasing. At 3 it becomes 0, and again it starts to increase. This is the graph of f dash of x, some random curve. Right now, sorry, f of x. This curve is f of x, some random curve. At the point 3, slope becomes 0. And f of x becomes, it is decreasing in this interval, minus infinity to 3, and again it starts to increase after this 3. So this is the understanding. Clear now? So what interval? Find local extremum means local extreme point is x equal to 3 and its minimum value, that will be f of 3. So f of 3 is the minimum value. This is the minimum value, minimum of f of x. When you have to find the minimum or maximum value, then we have to use this. So what is f of 3? F of 3 is 3 square, that is 9, minus of, remember you have to substitute f of x. So in f of x, that will be the curve for which we have to find maximum or minimum. So don't substitute this 3 in f dash, that will be wrong. So f of x will be this curve, and in this curve we have to substitute the value. So here 3 square is 9, minus of 6 into 3, 18, plus 8. So what is the answer, students? 9 minus 18 is minus 9, plus 8 is minus 1. So f of 3 is minus 1. Minimum value is minus 1, and the point of minimum when it is asked, that means x is equal to 3. Or we can write 3 comma minus 1, that is the point. Now we will see the solution. Given f of x equal to this, what is f dash of x? First we have to find f dash of x, and f dash of x greater than 0 means the function is increasing, less than 0 it is decreasing, and equal to 0, that means we have to find at the point slope is 0, so it is parallel to x-axis. So we have found the regions for all the cases, and f dash changes its sign from negative to positive at the point 3. So it has minimum value at x equal to 3. And what is the minimum value? Minimum value will be f of 3. That is, we have to find the minimum value, that is minus 1. Again, easy question. Next is second derivative test. Now what is second derivative test, students? Again, for finding maximum or minimum, we have already seen through first derivative test that a function can attain maximum or minimum, then f dash will become 0. Now why do we have to find second derivative test? We will consider an example. First, before seeing the second derivative test, we have to know what is concave upward and concave downward curve, then it will be easy to understand. First I will explain in short what is concave upward and concave downward. Let's delete this fully, and first we will discuss it here. Concave upward and concave downward curve. Concave upward is nothing but a curve in the shape of a quadratic equation with coefficient of x square is positive. This is concave upward, and concave downward is, concave downward curve is just the opposite, curve like this. This is the concave downward shape. Now by observation, for a concave upward curve, when we draw a tangent, wherever we draw a tangent, this tangent will always lie below the curve, or curve lies above the tangent. So for a concave upward curve, always tangent lies below the curve. What about concave downward curve, students? Tangent is like this, that means tangent will lie above the curve. Here tangent lies below the curve, here tangent will always lie above the curve. That is the understanding or basic definition of what is concavity upward and downward. Next is, by using this observation, here this point attains minimum value for a random curve. Then what about the rate of change of slope? That is the second derivative. That means we have to differentiate 2 times, and when we differentiate 2 times, what is the first derivative actually? It is the slope, rate of change of y value, that gives the slope of function. Next, what we are doing? Second derivative, we are differentiating the slope again. That means rate of change of slope, how the slope value changes. By observation, if you draw a tangent at each point through increasing x values, then what are we observing here? This slope is higher and it keeps on decreasing, slope keeps on decreasing, and again it keeps on increasing. So this first is, slope is, this value is very less, again it comes to some value, minus, say this is minus 5, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So slopes keeps on increasing. Now what does it mean? That means f double dash keeps on increasing means f dash keeps on increasing means f double dash will be greater than 0. So for this curve, f double dash will be always greater than 0. What about this case? Again, rate of change of slope. So slope of tangent keeps on decreasing for this case. So what we observe from this? Slope decrease, that means f double dash will be less than 0 for concave downward curve. And what about concave upward? Concave upward corresponding to point of minimum, and concave downward curve correspond to point of maximum. So that means when we have to find the point of minimum, double derivative at the critical point, at this point it will be positive, then the point will be minimum. If a point of maximum needs to be found, then double derivative at that point of critical point, it will be negative. So that is the understanding. Clear now, students? Now we will see the second derivative test. Again we will consider a continuous and differentiable function in the open interval. Now if f dash equal to 0 at some point alpha and f double dash is less than 0, if this point is less than 0, what does it mean? Slope keeps on decreasing. That means point will be maximum. So it gives the value of maximum, local maximum or relative maximum of f. Similarly, when f dash equal to 0, that means alpha is a critical point and f double dash becomes positive at that critical point. Remember, we have to find f double dash at the critical point. So at the critical point, this value will be negative for maximum and positive for minimum. We have to change the sign. So negative means maximum, negative means maximum, it is less than 0 for maximum and greater than 0 for minimum. Right now, and what about if this value becomes 0? If f double dash also becomes 0, then we can't conclude if the point is maximum or minimum. Now f of x is a function. Now how to determine maximum or minimum value we have already seen. We'll just go through stepwise again. Find f dash of x and equate it to 0. Then we will find the critical points. Say the critical points are x equal to a, b, c, etc. Next what we need to do is find f double dash of x at the critical point. That is f double dash of a, f double dash of b, f double dash of c, and see the sign. If it is positive, that corresponds to minimum value. Say a, f double dash of a is greater than 0, that means a is a point of minimum. F double dash of b is less than 0, that means it is a point of maximum. Next step is, if f double dash is greater than 0, it is a minimum value, and if it is less than 0, that corresponds to maximum value. Suppose if it is equal to 0, then we can't determine using second derivative test. Then what we need to find is, use the nth derivative test. That means again we have to differentiate the function. And if f triple dash of a, that means third derivative, is not equal to 0, then that point is not a critical point. So when again if we are differentiating after, if f double dash becomes 0 and f triple dash becomes non-zero, then that point will not be critical point. It is called a point of inflection. And again if this also becomes 0, then we have to differentiate this again. If f triple dash becomes 0, then find the fourth derivative at the critical point. Always remember, we have to find at the critical point, that is at a, b, c, etc. Whatever is, first we have to find f dash of x and equate it to 0, and then we will get some values for critical points. Let that be a, b, c. We have to substitute f double dash of a, f triple dash of a, f fourth derivative of a, like that. So if second derivative is 0, then we go to third derivative test. Then third derivative is non-zero means it is not a critical point. That point is not a maximum or minimum value. If it also becomes 0, then we will go to fourth derivative. Then if fourth derivative is a positive number, then again minimum. Just like second derivative. Remember, whenever we have even powers derivative, even order derivative, at that point if it is non-zero, If it is positive, then it corresponds to minimum value, and negative means it is a maximum value. And if it is 0, then we will proceed to other derivative, higher order derivatives. And remember, odd derivatives if 0 implies that value is not a point of maximum or minimum. So this is nothing but nth derivative test. That means we are differentiating n times to find maximum or minimum. And we will proceed to this only when f double dash is equal to 0. Otherwise, we have to consider the sign of whatever is first when we are differentiating. Again, f fourth derivative at a is positive means it is a point of minimum, and if it is negative, it is a point of maximum. This process will be continued as long as we get a non-zero number at even derivative of x. Second derivative of f is said to be 0, then a is said to be a point of inflection. And why do we call that as a point of inflection? We will consider one example. We will consider two curves, y equal to x square and y is equal to x cube. We already know the graphs of these two curves. What is the graph of y equal to x square? It is like this. What is the graph of y equal to x cube? It proceeds like this. Now, what is the differentiation of this? This be f dash of x. This is again another function. Now what we will do is find f dash of x. Differentiate once. That will be 2x. What is critical point? Critical point is f dash of x equal to 0, which means x will be 0. 2x equal to 0, x equal to 0. Now what we will do is find f double dash at 0. What is f double dash of x? That will be 2. Differentiation of 2x. Then what we will do is find f double dash at 0. That will be again 2. Whatever value of x is replaced, it is a constant function, so value is 2. Now coming to this case, again f dash of x is 3 times x square. Again f dash of x equal to 0 means what is the critical point? X square will be 0, so x is equal to 0. Now what we will do is find f double dash of x. F double dash of x will be 6x. Now f double dash at 0 we have to find at the critical point. So f double dash at 0 will be 0. When f double dash becomes 0, that means it is a point of inflection. Next what we need to do? Again differentiate, find f triple dash of x. That will be 6. And what is the condition? When f odd derivative of x is non-zero, then that point is not a maximum or minimum. Here by observation, 0 is a point of maximum or minimum? No. So that means it is, by this test we can identify. Remember this easier case, what we are actually doing when we have an even order derivative, if it is less than 0 at the critical point, it is a maximum value. Greater than 0 at the critical point means it is a minimum value. For odd order derivative, it must be 0. If it is non-zero, that is not a maximum or minimum point. For example, find the local extrema of this function using the second derivative test. Now what we need to do? First step is to find f dash of x. F dash of x is 3x square minus 18x minus 48. 3x square minus 18x minus 48. Now if this is 3 times of x square minus 6x minus 16 into 3. Again we can write this as 3 times of x minus 8 into x plus 2. Correct na? We already know how to factorize. Then that means when f dash of x equal to 0 implies what is the value of x? X can be minus 2 or 8, minus 2 or 8. So these are the critical points. Next what we need to do? Mark the critical points minus 2 and 8. For first derivative test, we have to take some number and substitute this value. For second derivative test, what we do? Find f double dash of x. F double dash of x will be 3 times of x square differentiation is 2x minus 6. Now f double dash at minus 2 will be, then this will be a negative number at minus 2. This value is minus 4 minus 6 is minus 10 into 3 minus 30, which is less than 0. And what about f double dash at 8? That will be 2 into 8 is 16 minus 6 is 10, 30, which is greater than 0. So f double dash at the critical point is less than 0 means that point is maximum point, and greater than 0 means it is a minimum point. So how will the curve be? Cubic degree with r power of x cube. Then this minus 2 will be a maximum value and 8 will be minimum value. This is a rough sketch of this graph. Do you understand, students? Easy. Now we will see the solution. Suppose we have to find the maximum and minimum value at this critical point, then we have to just substitute. Maximum value will be f of minus 2. So in the function we have to substitute minus 2. Similarly, minimum value will be f of 8. Now we will see the solution for this. F of x is given. What is f dash of x and f double dash of x? Then f dash of x equal to 0 means what are the critical points here? Minus 2 and 8. Next, find f double dash at the points. F double dash at 8 will be 30, that is greater than 0. So this point at 8 is the minimum value. So it has a minimum value at 8, and what is the minimum value? That is f of 8. So just substitute in the function, then we will get the answer. Similarly, at minus 2, f double dash is negative, that means this is the point of maximum, and maximum value is f of minus 2. That comes out to be 124. Clear now, students? Easy questions. Next, what is point of inflection? We have already discussed. Point of inflection are the points where critical point f dash becomes 0, but f double dash is also 0 at the critical point. Those points are called points of inflection. An arc of a curve f of x is called a concave upward or downward based on the position of tangent with respect to the curve. We already seen concave upward and concave downward. Tangent is always below curve means it is concave upward curve, and tangent is always above the curve means it is concave downward. That is what is given here. Now the points of inflection are a point where the curve changes its curvature. It changes its nature on the curvature. That means it changes its nature from concave upward to concave downward, or concave downward to concave upward. What does it mean? That means curve will be something like this. It is something like this. We'll draw it better. The curve is going something like this. That means what is the understanding? The curve changes its curvature, say at this point. For example, random example, at this point the curve becomes 0 and again it changes its curvature. Here the f dash is increasing always. Again in this region also f dash is increasing. At this point f dash becomes 0. That means this curve, what is the shape of this? It is concave downward, and this is concave upward shape. So what is the understanding? Curve changes its curvature from concave downward to concave upward, or it can change its curvature from concave upward to concave downward. Both are same. So what we actually need to do is break this curve, concave upward and concave downward parts, into two regions. When the curve is looking like this, that is the concave upward. Similarly in this direction. Similarly for concave downward also we have two cases. By observation, this part corresponds to concave downward and this part corresponds to concave upward. So the curve changes its curvature from concave downward to concave upward. For this case, concave upward to, that is this part, to concave downward. Point of inflection is the point where curve changes its concavity. Concavity or curvature, both are same. And tangent to the curve at the point of inflection crosses the curve. F double dash will become 0 and curve changes its curvature. That means tangent will pass at that point. Tangent will pass at the point of inflection. Next is maximum and minimum value of discontinuous function. We will discuss one by one with some cases, examples. Minimum value of discontinuous functions. Now the following 4 cases arise for minimum as well as maximum value also we can see from this. Now what is this case? First one is, in the neighborhood of A, take f of A is this point, f of A plus h and f of A minus h is like this. Now this is some arbitrary curve. F of A is defined at this point and f of A minus h will be greater than f of A. Similarly, f of A plus h is also greater than f of A. So what is the value of f of A in the neighborhood? It is the minimum value in the neighborhood of f of A. That means this point corresponds to minimum value. Remember, when we are finding minimum or maximum value of function, it does not necessarily mean the function should be differentiable or it should be continuous. It can be in discontinuous function also. Still we can find maximum or minimum value through the basic definition of maximum or minimum. So don't forget that here f of A is minimum value. Why is that? Because in the neighborhood of A, this is the minimum value among all the values in its neighborhood. So that means it is minimum. Similarly, we will consider another case. Now the function is like this. In this case, f of A is equal to left hand limit and it is not equal to right hand limit. But still this point is the minimum value among the values in the neighborhood. So in the neighborhood between f of A minus h to f of A plus h, this is the minimum value. That means it is again point of minimum. So we always need to remember the basic definition while finding. For a discontinuous function, we will just calculate the limits, f of left hand limit and right hand limit, f of A minus and f of A plus. So what is the understanding? F of A is less than f of A plus h. Obviously f of A plus h is greater than this. Similarly, f of A is less than or equal to f of A minus h. Limits are same. Next is, left hand limit will be greater but right hand limit will be equal to the function value. Or it need not be equal, still this is the minimum most point. Similarly, it can be equal also, but among all the values, this will be the minimum value. That is the understanding of minimum of discontinuous function. Next is maximum of discontinuous function. Again, similar to the previous 4 cases, we can discuss the maximum values. Okay, now in this case, f of A is defined to be some other point and limit here right hand and left hand limit are not different from f of A. So what we understand from this value does not necessarily exist in the interval, but still this is the maximum value in the neighborhood. That means this is the maximum value. A is the point of maximum. For second case, again it will be simpler. In this point, if it exists but left hand limit and right hand limit are different and the value is less than f of A, that means A is the point of maximum. F of A is greater than f of A plus h, true. f of a plus h is here. Similarly, it is greater than f of a minus h. Again, next case is f of a will be equal to left hand limit, but right hand limit will be lesser than f of a. That means again this is the point of maximum, because f of a is the greatest value among all the values in the neighborhood. That is the understanding. No? Next case. Again, now right hand limit and function value is same, but left hand limit is lesser. So this is how we should find. Using the basic definition of maxima or minima, we have to check the function has maximum or minimum value for the discontinuous functions. Next is find the extreme points of f of x equal to this curve. Find the extreme points of f of x equal to 3x power 4 minus 4x cube plus 1 and state whether the function has local maxima or minima at those points. Now first is extreme points of this function. That means what we need to do? First differentiate, equate it to 0. F dash of x is equal to, what is the differentiation of this? That will be 3 into 4 is 12x cube minus 12x square. Now this is equal to 12x square into x minus 1. Now what we need to do? F dash of x equal to 0 means x will be equal to 0 or 1. 0 or 1. Next what we need to do? Find f double dash. F double dash of x is equal to, again differentiate, then we will get 12 into 3 is 36 x square minus of 12 2s are 24 x. Now we have to check if this value is greater than or less than 0 at the critical points. So f double dash of at the critical point 0, this is 0. At the critical point it is 0. And what about at 1? F double dash at 1. F double dash at 1 will be, substitute 1, then we will get 36 minus 24, that is 12, which is greater than 0. That means f double dash becomes 0 means this is not a critical point. This is not a point of maxima or minimum. F double dash is greater than 0 means 1 is the point of minimum. That is the understanding from this. So we have to find f of 1. F of 1 is the point of minimum and this function has no maximum. So f of 1 will be, substitute 1 in the f of x, that is 3 minus 4 plus 1. The value is 0. So this is the understanding. Okay, now we will see the solution. Given f of x equal to this, f dash will be 12x cube minus 12x square. F dash equal to 0 to find critical point. And what are the critical points, students? 0 or 1. So x equal to 0 or 1. Next what we need to do? See, f dash changes the sign from negative to positive or positive to negative. This is the first derivative test. That means f has a minimum value because it changes its sign from negative to positive at 1. And what about at 0? It does not change its sign in the neighborhood of 0. F dash remains same value. So there is no maxima or minima at the point 0. So this is the solution using first derivative test, and we have solved the solution using second derivative test also. No matter what derivative we use, answer should be same. So whichever is comfortable for you, you can use that, as long as it is not mentioned by finding using second derivative or first derivative test. Then you can use any method. If it is mentioned, use the appropriate method. So with this we will end this session, students. And remember, keep learning and keep growing with Namma Tapasya. Success is yours line by line. Endigu endendigu Namma Tapasya. Thank you, students.